Let's look at some acids and bases now. Okay, and so we'll start with the most simple thing, which is conjugate acid and base. Okay, so first task is to write out the conjugate acid or base of any molecule. So let's go ahead and write the conjugate base, okay, of all of here. Conjugate base of A. NH3, which is ammonia. So when you're drawing the conjugate base of anything, that means you have to remove a proton. Okay, so if you're removing an H plus from anything, so for example over here, if you're removing H plus, then you're left with NH2 minus. Okay, because then if you put the H plus back on, then the H plus and minus, that would cancel out and give you the ammonia back. All right, so that is for ammonia. Let's take another one, H2. The conjugate base of H2, again you're removing H plus, so which means that this one, okay, which is called hydride. All right, this one was amide. And let's look at some more over here for water, H2O minus H plus yet again, and so remove one of the hydrogens and you get OH minus, which is, as we know, hydroxide. And then let's try something else. An alkyne, if you remove a hydrogen from here or a proton from here, you will end up getting this ion. Okay, this is called an alkanide ion. We will learn more about this. Don't worry about the name yet. And let's take another one, a conjugate base of H2SO4. Remove one hydrogen or one proton, get HSO4 minus. Okay, hydrogen sulfate. You can remove one more, okay, from here, and so this becomes SO4 2 minus sulfate ion. Okay, so which means that H2SO4, this is conjugate base, and then again this is another conjugate base, okay, for sulfuric acid. All right, and then let's take another one. If you had hydronium ion and now you were to form the conjugate base of this, again you remove a proton, so now you're removing H and then the plus, so which means you're left with H2O. So in this case you get a neutral species at the end. Okay, all right, so now let's do some conjugate acids. There will be the opposite, okay, of what we've just done, which means we are adding H plus, okay, in this one. So let's start with CH3 and H2. So now you have to add H plus, and so you have to also realize where the hydrogen is going to go. Okay, and in the conjugate bases you were trying to figure out where the hydrogen will come out of, and we didn't really have much choices, but here you have a choice of where to add the hydrogen. Do you add it to carbon or do you add it to the nitrogen? And you add it to the nitrogen because otherwise carbon will have more bonds on it. Okay, so you can't have more than 4 bonds on that, on carbon. So make sure you don't violate that rule. Okay, so which means NH3 over here, it's 1, CH3, CH2 minus conjugate acid of that, add a proton. So whatever has the negative charge is the one that's going to get the hydrogen. So this becomes CH3, CH3, and alkane, and CH3, COO minus, add a proton to form the conjugate acid, and CH3, COOH. Okay, let's do one more. HSO4 minus, and I'm doing this because we did this before with the conjugate base, okay, because we made the conjugate base for sulfuric acid, which is this, and if you were to form the acid back, you will add the proton, okay, and so then you will get sulfuric acid right back. Okay, this is how you would do conjugate acids and bases. Now let's look at a little bit of strength of acids and bases. And strength of acids, let's do that first and we'll do bases, okay? And so if you have something like CH3 COOH, which is acetic acid, and CH3CH2OH, which is the alcohol, okay, which is a stronger acid. So you look at the two compounds and you first identify your acidic proton, okay? Acidic proton is attached to electronegative element, okay, usually oxygen, not carbon then, okay? So which means that this is our acidic proton, this is our acidic proton. So which one is a stronger acid? This is stronger. But then why? Because there are two oxygens, therefore H can leave easily. In alcohol there is only one oxygen, alright, so it's not so much of ionizable, whereas in carboxylic acid it is easy to ionize, alright. So that is one example. Let's look at another one. So now let's take an alcohol and let's take an alkane. So here we see a comparison where you have a proton that is connected to oxygen, and here we have a proton that's connected to a carbon, which means this is not even really acidic because carbon-hydrogen bond is virtually non-polar. Okay, so this is stronger. Okay, again because hydrogen is attached to oxygen. Okay, so that's more polar bond. All right, let's look at another one. CH2 versus CH. Alkene versus alkyne. Alkynes are stronger, and this is not because of polarity anymore, okay, because now here you have CH bond and CH bond, so the reason is something else, and the reason is the delocalization possible after hydrogen leaves, okay, and that has to do with the fact that with CH2 CH, okay, that's the conjugate base for alkene, and here is the conjugate base for alkyne, and triple bond provides space, okay, for electrons to delocalize. And that is how you figure out whether something is a stronger acid or not. And then let's do one more really quick. Don't have much space left here now, but CH3 CH2 COOH versus CH3 CHCl COOH. Okay, in this case this is stronger because of inductive effect. Inductive effect is because of the chlorine that is pulling electrons towards itself, and because this chlorine pulls electron towards itself, it's easy for this hydrogen to go away, okay, and that is not possible in the first case.